Dear students, Namaste and welcome back to a new mathematics session. As we all know that we are very close to our half-yearly examination, we have to start our revision. So today is our first revision session and we will be going for the first chapter, that is real numbers. Let's have a quick review of the chapter real numbers from the NCERT textbook.
We already know that rational numbers and irrational numbers together form real numbers. Now, rational numbers are the numbers which can be represented in the form p by q, where q not equal to 0. These numbers can be terminating or non-terminating, whereas the numbers with which neither terminate nor repeat are called irrational numbers. From this, we can conclude that all numbers are real numbers. Next, we shall revise the fundamental theorem of arithmetic. It states that every composite number can be expressed or factorized as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. Let's recall this concept. First, let's differentiate composite number and prime numbers. Composite numbers are the numbers which has more than two divisors. The smallest composite number is 4. Whereas the prime numbers are the numbers which get divided by itself and 1 only. And the smallest prime number is 2. The first statement states that every composite number can be expressed as the product of primes. This means that we can write the product or factorize composite number in primes. For example, the number 2260. Here we have factorized 2260 as 2 into 2 into 5 into 113 as the product of primes. So we have proved the first statement that every composite number can be expressed as the product of primes. The second statement is that the factorization is unique apart from the order in which the prime factors occur. This means that we can either write as 2 into 2 into 5 into 113 in ascending order or in descending order, that is 113 into 5 into 2 into 2. Here we have proved both the statements. Now we shall discuss about the irrationality of the number root 2. The value of root 2 is 1.41421356237309 etc. That is non-terminating and non-repeating. And the numbers which are non-terminating and non-repeating are called as irrational number. So we know that root 2 will be an irrational number. But when we have to prove this with the help of a theorem, we have to remember two important points. First, we are going to use contradiction to prove this theorem. That means we will assume that root 2 is a rational number. If any number divides the square of a number, then it will divide that number also. This will help you to explain the theorem. Next, moving on to rational numbers. We already know that they have terminating or non-terminating decimal expansions. Let's learn more about terminating decimal expansions. Suppose we have a rational number 0.425. We can write it as follows. Here we cancel the common factors between the numerator and denominator, and by observing the denominator we write the conclusion. Here we can say that any real number which has a decimal expansion that terminates can be expressed as a rational number p by q, where denominator is a power of 10. That is, q is in the form 2 raised to n into 5 raised to m, which are the prime factors of q and n. N and m are some non-negative integers. And the theorem states that let x be a rational number whose decimal expansion terminates, then x can be expressed in the form p by q, where p and q are co-prime, and the prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. The converse of this theorem also useful for us. Let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. Then x has a decimal expansion which terminates. Now let's think about the rational numbers whose prime factorization of q is not in the form of 2 power n 5 power m. They are non-terminating and repeating rational numbers. There is a theorem for this which states that let x is equal to p by q, where p and q are coprimes, be a rational number such that the prime factorization of q is not of the form 2 power n into 5 power m, where n and m are non-negative integers. Then x is a decimal expansion which is non-terminating repeating.
Dear students, now we have revised all the basic concepts from the chapter Real Numbers. After watching this video, I request all the students to solve the examples and exercise problems independently, and after solving those questions, you are requested to solve the worksheet which is sending along with this video. While solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.